Oh, what a day! What a lovely day!
Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you're new to this channel, or you have not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside each of these shows while they're live, and there's a PayPal link in the info box below the video once it's rendered. But most importantly, if you would like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the shape of the Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show. Sharing the show increases the live audience, of course, but this in turn increases the chances of a more diverse panel. So please share the show. And one last time, if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now we are joined by Sleeping Warrior. How are you doing?
Morning.
Evening.
I wasn't sure if it was on Patricia's show or Nathan's show then. I mean, you're like an hour and 40 minutes later than normal. What's going on?
It's the Patricia Steer effect, is it, being an hour and 40 minutes late?
An hour and 40 minutes, I think she classes as fashionably late still. It's like, come on, Patricia. It's like 11. She's supposed to start at 11 p.m. in UK time. But every minute that she's late, right, that's like a minute that I'm thinking about should I be going to bed? Come on, Patricia. Come on, get some punctuality in your life. Give us Brits a chance to listen to your show.
Yeah, I tend to watch the first half only, I won't lie.
I wasn't having a bitch then. She knows I love her, but she drives me mad when she doesn't start on time. She sends me the link saying, started at 6 p.m. Eastern or Pacific or whatever time zone she's in. And I think, right, that means 11 o'clock start again. Right, okay, then I'll try. 10 past 11, quarter past 11, 20 past 11, no sign of Patricia. Started in a minute, doesn't happen. By the time it starts, it's like 1 o'clock. Like, come on. Anyway, let's not moan too much. Did you watch the physicist teacher have a chat with me last night?
I did. It was excellent.
You know, the guy's such an affable guy, a likable guy that you can't really be horrible to him. But I wasn't going to let him win.
Well, he didn't offer anything. I mean, he literally offered zero scientific evidence. His opening gambit was to say, look at the pictures from NASA. And your assertion was that there is no scientific evidence of the sphere Earth. So to go immediately to NASA pictures was a big disappointment.
To be honest, I mean, we did have a structure. Morning, John. We did have a structure, and I did give him pre-disclosure of what we were going to talk about. And he responded with what he was going to give me back by way of answers. And then I gave him back what I would respond to his answers with my answers. And it was orchestrated. It was controlled. There was total full disclosure. There were no rabbits in the hat. And to be honest, it was like, I don't know, it was like he just gave me, it was just like the gift that kicked. He didn't answer the questions. Now, bearing in mind, he's a physics teacher, right? And he sent me the exam paper, which, let's be honest, he gave me a harder paper than what he gave me with the mock papers he gave me. But nonetheless, if I answered a question the way that he started off answering my first question, which was to do with the scientific method, he would have got 0 marks for that. And I was like, come on, stay on topic. The question is this: what scientific evidence is there for the sphere? And be it curvature or rotation, one of them 2 points needs to be addressed. And he was just appealing to all the authorities. And I was like, come on, this is like terrible as an answer. You're not answering the question at all. So I had to interrupt him and get him back on track. And it was like he had a brain freeze. And I mean that in the nicest of ways. I'm not having a go at him, but he just wasn't answering the question. And ultimately, in the end, when I summed up the 5 questions I asked him, he didn't really give any decent answers for any of the 5 questions. And I thought, really, wow, for a science guy, for a physics teacher, and he had pre-disclosure. It's like, I don't know. I think World Cup fever might have took over his brain, and he forgot all his answers that he was going to talk to me about. It was bad.
I talked to him last night.
Oh, how did that go?
Yeah, he's a good man. I enjoyed talking to him.
You're a bit quiet, John.
Say again?
You're a bit quiet.
Yeah, I don't have my microphone on. I didn't want to put that stupid thing on my head.
Okay.
We're not live, are we?
We are.
Yeah, we are live.
Yeah, I'll save my comments for afterwards. Then. Good thing I asked.
Good job, you asked,
I want to keep it private for right now.
Fair enough.
And
Well,
I just
the jury's out for you then.
Well, just to segue away from that then, I mean, what it made me think was, what is it that makes somebody like that, who is literally, you know, full of joy and glee when Anthony's talking about the scientific method in relation to flat Earth, you know, he's all keen, but then when the shoe is on the other foot, what makes a man like that come forth with appeals to authority and non sequitur conclusions? What makes a guy like that do that? I don't understand. Is it just the brainwashing is that good?
I do. If you've been through the university, I mean, we've been through the same standard. We got to the same level almost academically. If you've vested into academics and education that much that somebody's now questioning the paradox or creating a paradox in my mind, that he's thinking, nah, this isn't a paradox. This is easy to explain, but he doesn't answer it properly. Then what he's doing is resisting the criticism of the academics in which he was taught, learned, now teaches, and it's basically his world. So it's kind of like Werner von Braun, you know, the NASA rocket engineer that died, but had the Psalm 1912 or whatever it was on his headstone that said, "For the heavens show the glory of God, and the firmament show His handiwork." That's like the antithesis of anybody that was in NASA, especially a rocket scientist. So it's kind of, for me, it's kind of like me coming along and questioning his science I'm like the Antichrist, and it's like, how dare he? You're questioning everything that he's been taught is true. That's not an easy paradigm to work your way through, because you have to think about things logically and provide answers that you've never been asked the questions to before. You've always been asked the questions that support the official version. You've never been asked the questions that challenge the official version, regardless of the maths. Now he's having to think, and he has to answer questions like a science paper or an exam paper, and you have to answer the questions. And he wasn't really doing that. He was being really nice, polite, affable, friendly, but not doing that which he was supposed to do, which was win the debate. And he didn't do that. He was. Do you know what it was similar to? It was like Jaron. When Jaron first went in that non sequitur, he demonstrated, or he behaved the way Jaron did, which was very likable, affable, friendly, but he got destroyed. And I think it's more because he didn't have the skills at debating properly than not knowing the stuff. But I guess we'll see in the next week or two how he gets on, because I know that other people have been in touch with him since, and he's been asking me how these people sound out. And, you know, you walk through the valley of death in flat Earth. We've all got to have our journey. He'll have his. And he'll meet good people, he'll meet bad people, but ultimately we'll find out where he fits in the whole flat Earth discussion by how he is in the next few weeks. But it's going to be definitely interesting to watch.
He'll be a flat earther within the week.
I think so. What do you think, Nath?
Well, it seemed to me like he was, during the discussion, looking for the opportunity to beg the question, and when you highlighted it on multiple occasions, not by way of saying you're begging the question, but by pointing out that, you know, there's going to be an R in there somewhere, and he denied it. No, don't need R, don't need R. And then when he starts explaining it with R, and you're like, well, what's that R then? Well, that's not R. You know, in other words, cognitively, he knows what's going on, but he's fighting it. And it's really interesting to watch. You could see the pained expression on his face as he was doing it, because he knows what he's doing. But like you say, he's been taught it. And you're asking for scientific evidence as opposed to what have you been taught that tells you this is true.
It's not easy, though, when you've got something challenging everything that you've been spending. I mean, the guy's been through, he's done a master's in biology. He didn't do it in physics, but I don't think that really matters, because it is one of the key sciences. It's not like it's astrophysics or anything like that. It is actual one of the core science principles. And I think that when something challenges that whole, what's the word I'm looking for? The skeleton, the whole infrastructure of
foundation.
That which we're taught to be true.
The foundation.
Yeah, the foundation. That creates like a, oh, bloody hell, I haven't got mine open. True.
The foundation.
Yeah, the foundation. Did you get him?
I did.
I didn't have mine open. I didn't know the link was out. Right, sorted now. I'm ready. So welcome back in, you know, trolls. Anybody that wants to join, I'm paying attention now. You nearly got me.
John, you still there, John?
Yeah.
Oh, jolly good.
Yeah, Alistair's a good man. He's got a good head on his shoulders. We were all there at one point, you know. So I would say just be patient. I didn't listen to the whole hangout, just parts of it. You know, I commented to the parts that I listened to. I went back to the beginning, and it was easy to, how would you say, destroy those.
Yeah, but I didn't want to do it that way.
Yeah, and I wasn't rude about it. I just destroyed about his first 6 points. I don't know if you've seen that. I think I sent it to you.
Yeah, but I didn't want to destroy him. I wanted to take the wind out of his sail, but I didn't want to destroy it because, like I say, he'd been up against Dell and he got blocked in sheeps and neeps before he had a chance to speak. I wanted him to feel as though we were approachable and he'd just come across two crazy guys that were in bad moods or whatever.
Sorry to interrupt. He's in the chat saying I'll come in. Just click the link in the info box and you can just join.
He should be in work. I was working on the assumption that he had stuff to do.
Fair enough.
Sign exam papers.
He's all keen by the looks. It's GCSE physics A level and maths or something like that. I can't remember his name. Is that the name?
Yeah, I'll tell you what I'll do. I'll just send in the link in Skype because
yeah, then he's definitely got it. But
he knows how to work Skype. He's not got his head around Hangouts yet.
Fair enough.
So the link's in Skype there, Al, if you want to join. But it means that now we can't talk like from the heart. We have to be polite and friendly now. And it's like we were actually saying what we really thought. He needs to log on. It'll be 5 minutes. Don't know what that means, but he'll be in shortly. But yeah, he has the link.
Hey,
I'll be quiet over here.
It's all good.
Did you watch the Hangout yesterday with the teacher?
That was excellent. I loved it, man. Nathan in the chat box, he was like he wanted to jump on his throat.
Yeah,
he's a good guy. He looked like a very honest guy, you know. So yeah, we got to take it easy on him. He'll get there.
He's had a bad ride so far, and I mean that with in the nicest way I can. He's just met two of the most aggressive guys in Flat Earth, and that's not representative of Flat Earth generally. But that being said, he's going to get a baptism, isn't he? At some point, someone's going to come across him that basically pulls him apart heavily. I don't know. I guess we'll see in the next week or so how things go. But do you know we would like to really see have a conversation with him? Mark Sargent, because he's one of these affable. If you get two affable guys, you generally have a really good conversation.
That would be beautiful. Oh yeah, I will watch that big time.
Yeah, Mark Sargent, if you're out there listening, or if anyone's got access to tell Mark, you should get this guy in because that'll be a really good conversation for the two of you to have.
And as you can see, he's a very approachable guy. So yeah, it's good stuff.
He is. He's a nice guy. He's got a crap car, though. He's got a little Corsa, and there's nothing wrong with Corsas per se, but a guy at this point in his life, he should be on at least, I was going to say an Escort then, but a Focus, a Focus, but he's still on a Corsa, so I reckon he needs a pay rise.
Can you guys hear me?
We can.
Cool.
Bit quiet, though, Choc.
How about now?
Yeah, that's good.
Cool.
Did you watch the Hangout yesterday with the teacher?
With the teacher? Oh, yours on your channel?
Sure.
Nah, I caught it at the end. I didn't know it was on, but I didn't watch the replay of it.
You didn't?
No, I didn't watch it.
Oh, Choc, you let me down, man.
Not yet, anyway.
Well, it might be coming on, so you might get a little bit of a thingy. I don't know, like a one-to-one.
Crash course on it.
The only problem is he's going to come on and he's going to want to talk about his video that he's just released, but Nathan's not seen it yet. I've seen it. It presupposes R. But no, it asserts that correlation is causation for the purposes of gravity. And I can't accept that.
Yeah, I did catch like the very end, but I had to go. I wasn't able
Hey,
to watch
good to have you.
but...
Is that you?
Yeah, that's me. Am I on?
Yes, you are. Good to have you.
Right, I'll keep the gob shut then and not ruin your show. Just
No, feel
sorry,
free. We're talking about you. That gives you a perfect invitation.
Well, I knocked the stream off when I logged on because I didn't want it to, play in the background. So I've missed the last 2 or 3 minutes. Yeah, Sorry,
you've missed is
what should I be saying?
all you've missed is Chocolate was saying that he only caught the last 10 minutes and he hasn't caught up to speed. But then I said, well, he's brought out a video in the last hour or so, I think, basically claiming correlation is causation. But Nathan's not seen it. John hasn't seen it, I don't think. And Chocolate definitely won't have seen it.
I did send it, Nathan, on Twitter from one of my other from a Twitter account. I've got 2 YouTube accounts. One of them is pretty much dead, but I've got a Twitter account associated with it. So if you get a tweet from someone called Science Toys and Gadgets, Nathan, that's me, and that's the link to the video.
Okie dokie.
Who?
Cool. Just tell us. Just verbalize it. Just tell us what it is.
Oh, sorry, we're there. Right. Sorry. I'm not very good with IT. Anthony will tell you all that. Yeah. Well, basically, I mean, last night the video for me, I got in touch with Anthony because I wanted to set an example to the kids that I teach about how a debate should, how 2 people with different views can get together and chat and not fall out and not shout, and I understand it wasn't for me to come in and say, right, I'm going to give you proof that the Earth isn't round, isn't flat. But from my point of view as well, you've also got to understand I'm quite new to all of this. So a lot of the questions I was raising, I'm sure you've heard like 1,000,000 times over. What about the pictures? And so I'm sure you've heard that thousands of times. You're probably sick of hearing it. But for me, being new to like looking at all this, that's still a question that's relevant to me. Does that make sense?
Anybody gonna feel that?
Anybody.
Yeah, it makes perfect sense.
But anyway,
Thanks. Do you want to give a mic check? Because I'm not sure that you.
I can't hear anybody.
Can you hear me?
I can hear you, yeah, and I can hear. Was that John who just spoke then?
Yeah.
Yes.
Nathan's normally paying attention. I'd expect him to be chomping at the bit. Are you there, Nath?
Yeah, I'm paying attention.
All right. Okay. So he's just letting you speak then.
All right. Oh, cheers, Nathan. But yeah, the video I sent this morning, basically, one of the points I really wanted to make last night, which I did, but I didn't labour it enough. Essentially, if we look at the presupposition idea that, if Eratosthenes had presupposed a sphere, for his experiment to get an R value, would we both agree that if the Earth was a sphere, the R value he got from it would be pretty much the correct R value? Would we agree that?
But that's literally begging the question.
Well, no, it is. I think that unless I talk through the entire video, I think a good thing perhaps might be to, if you've got time to watch it, because it could take about 15 minutes, and I don't want to like ruin your show and gate crash it, but it'll take me probably about 15 minutes to get through the point. But essentially, I think the video I've sent you a link to, the new one I've come out, I think it begs a really, really good, difficult question to answer. And I think what it does is it suggests that either the presuppositions were correct or there's been an absolute, I think that's the only thing it can suggest. But I'll let you watch that in your own time.
Well, tell us how they come to the conclusion, because hopefully if you can tell us, you might...
Okay.
Yeah, you go ahead.
Sorry, I didn't mean to speak over you there. When we look at F equals gm1m2 over r squared, we're essentially looking at force equals mass times acceleration. And the acceleration is gm1. That's my phone, sorry. The acceleration is gm1 over r squared, and the m2 is the mass that we're dropping. So if acceleration gm1 over r squared, that gives us 9.8, which is what we see in the real world, isn't it? We do see things accelerate with a acceleration of 9.8 meters per second squared. But when we look at where those numbers have come from, what I'm hearing, and maybe this is just because I'm new to the whole thing, but what I'm hearing is that Eratosthenes was discredited because he made the presupposition that the Earth was a sphere before he got his R value. And, I'm hearing that Cavendish was discredited because, his experiment was flawed, etc. Now, if Eratosthenes did make that presupposition and he calculated that R value, and Cavendish, got his gravitational constant, when we put those together with the mass of the Earth, which again, I've seen arguments where people knock how we calculate the mass of the Earth, if they all come together anyway to give us 9.8, which is what we see, it's impossible for that to have been worked backwards. These experiments started over 2,000 years ago. Nobody has sat and said, look, acceleration is 9.8 meters per second squared. So therefore, when I carry out my experiment in ancient Greece to get the radius of the Earth, and then in 2,000 years, when Cavendish carries out his experiment, we need to all make it work into 9.8. These were completely separate completely separate experiments looking into different things. Yet when they come together to predict what the acceleration should be, it works. Now, the only possible reason for that is that the presupposition that he made that the Earth was a sphere is correct, or there is some unbelievable fluke, some unbelievable chance that these numbers happen to create 9.8 when it could be any number, and that's sort of the point I make on the video.
Okay.
Yeah, I watched that video and I answered your questions and I sent that on Skype.
Oh, I've not seen that yet. Sorry, John.
Yeah, I sent it to the group where you and Anthony were in.
Right, I'll have to check that out. See what you've
Number one, they weren't experiments, either of them. Number two, G was backward engineered, and Brian Mullins showed that about 2 years ago. I sent you a video of that. He goes through it step by step.
Right. Well, I will definitely have a look at those two. Sorry, go on.
Yeah. Another presupposition that now listen, Aristosthenes. Number one, you have no primary sources from Aristosthenes, right? Now, number two, he not only assumed it was a sphere, he assumed the size and somewhat of a distance of the sun, right?
Mm-hmm.
He would have had to.
Get an R value, and you get an R value from a 2D circular plane model if the sun is.
Yeah, you cut off there.
Yeah, it all went a bit dead there, didn't it? I'd say that if he's got that R value based, because the experiment, I'm sure you're familiar with the experiment itself,
Yeah, that wasn't an experiment.
Well, the measurement, or the process he went through. If he supposed that the Earth was the sphere beforehand, then the R value he's got must be the radius of that sphere. I'm saying it's too big a coincidence that when we take that number and plug it into the acceleration that we should see, we do get the acceleration we should see.
Well, what's the cause of the acceleration?
Well, now that is a fantastic question, isn't it? Like, obviously, to me, there has to be a force. Force equals mass times acceleration. You can't have an acceleration without a force. Now, what you call that force, I'm going to call it gravity, but I don't think anybody, nobody on the world, I don't think, could sit down and tell you exactly how it works. And to me, that's the beauty of science, isn't it? We're still digging.
No, it's not. That's not the beauty of it, because as soon as you say gravity, you immediately invoke a cause, whether it be Newton or Cavendish gravity or Einstein gravity. Because I could call it anything. I could call it Dukel-Sloper-Gertz, right? Yeah. So you need to experimentally validate the cause. You know this.
Yeah, and that's what I would say. I mean, this just the argument I'm making, is that there's been 3 very separate investigations to work out G, to work out the mass of the Earth, to work out the radius. They've not relied on each other. They've all been done very, very separately. But when we put them together, so that is the experimental data. Now, you can say about those experiments that they are flawed because there was assumptions involved beforehand, and I totally accept that. But assumptions, presuppositions, they are either correct or they are incorrect. And I think when you put them all together and you do actually see the 9.8 as the acceleration, for me, that is more than enough to tell me that those assumptions were correct, because that's what we see time and time and time again.
So you said right at the beginning of this sentence, you said that there needs to be a force for there to be a movement.
Yes. Well, there needs to be a force to change a movement. So to change direction, speed something up, slow it down. If something's in motion already, it doesn't require.
If we're able to control the equilibrium state by varying the density of the relevant mediums, we can demonstrate that there doesn't need to be a force. We can just vary the equilibrium.
Sorry, go on.
Well, we can demonstrate with eggs. I showed you in the pre-hangout or in the pre-disclosure that we can vary the density of the relative experiments. We can vary the density and create movements without any force whatsoever. So if you need a force, how would the egg that I showed you in Foucault Word's hard-boiled egg experiment in the water, by adding salt to the water, change the density of the water around it, and that made the egg change its relative state by changing its position, but that requires movement, and it did that. So what was the force when we manipulated the relative density in the environment that the egg sat in?
So in that instance, the force to me, I'm obviously going to say the force is gravity, but gravity is acting on the egg and it's acting on the water.
Yeah, but hang on. The independent variable was this adding salts to the water, which changed the density of the water, which made the egg more buoyant. So the independent variable was adding salt. Therefore, the cause was adding salt, but the cause was not gravity.
No, the independent variable, you are right, was changing the density of the water, wasn't it? And the dependent variable was, I suppose, the equilibrium position for the egg, which is absolutely right. And you can see that cause and you can see the effect, but then you draw a conclusion, from that. And the conclusion that I would make is that the gravity is pulling down, obviously, on the water. It's pulling down on the egg, and the more dense medium,
but you've just redefined the scientific method, though.
Because sorry, yeah, I was just about to ask that. So why would you do that? You're a man of science, so why would you just insert this extra thing that you've decided is true, even though it's not in any way scientifically valid?
Well, that's it. I would say, and that's obviously where we're coming from different angles. I would say that there is a measurable force pulling things down towards the ground. That is verifiable. We can hang anything off a spring balance, for example, and measure.
Hang on. You accepted that the addition of salt to the water changed the density in the environment, therefore the egg was displaced, but then totally gone against the scientific method and said, I don't accept that independent variable anymore. I want to substitute gravity instead. Why would you do that?
No, I would fully expect when you put that salt for the egg in the water for the egg to rise, the explanation to me is that both, if I took that water without the egg and I tipped it upside down, it would be pulled to the floor. So there is a force pulling the water to the floor. If I drop the egg outside the beaker, it would fall to the floor. So there is a force pulling the egg. So we're doing it in an environment where both of those objects are going to be pulled to the floor no matter what.
But we're manipulating the environment and we're changing the relative densities relative to the things that are in the environment. And the independent variable is the environment that the egg sat in. It's not the egg itself. So we're manipulating that environment and we're causing that egg to displace. So the independent variable is the salt solution. But you're then substituting gravity, which is not the independent variable, and we're saying is nonsense, when you accept that the independent variable was salt. So it's like, how can you make the leap, the quantum leap from salt to gravity when it falls clearly outside the independent variable that we've just agreed was the cause for the experiment?
The force that's pulling objects down to the ground, whether we manipulate, we could manipulate the volume of water, the temperature of the water, we could have done all sorts, but whatever we do, we can't remove that downward force. I mean, you'll know if I took that beaker and let go, whether the salt was in the water or not, the water and the egg are in the environment where both are being pulled down towards the ground.
Yeah, but that's a straw man argument. Come on, we're specifically talking about the independent variable of salt water in that experiment, where we manipulated the relative environment that the egg sat in, and we changed the equilibrium state and forced a movement by virtue of salt. Now, we all agree that the salt was the cause, but what I'm asking is, why do you make the jump from the independent cause that was salt to gravity? Why? Well, it wasn't the independent variable.
If the argument you're making is changing the density of the water has an effect on the equilibrium of the egg, and that's your independent variable, and that's absolutely bang on. Yeah, that putting the salt in the water is what's causing that change of equilibrium. I guess what I don't understand is ignoring. Well, when it comes to the explanation, I mean, you observe a link, an effect between two variables, but then you have to go on and explain it using scientific ideas and things that have been validated in other areas.
No, you don't. He just did it in his experiment.
Yeah, that's what I was going to say. Give me an example of an experiment where you have an independent variable that you manipulate, cause effect on the dependent variable, and then somehow go completely off topic and talk about something completely else altogether that wasn't part of the experiment in itself, but could make that the conclusion. Name any experiment where that's ever happened.
So what I would say, let's say I'm doing an investigation at school where I'm looking at the resistance of a wire and how that changes with the length of the wire. My independent variable would be the length of the wire. Okay. My dependent variable will be the resistance I measure across that wire. But when we are done and we say, okay, changing the length of wire will change the resistance, we then ask why. And then I will start talking about collisions and electrons and, vibration of the lattice inside the metal, heat transfer as it moves into heat, etc. And that's what I feel I'm doing with the egg experiment. We've said, yes, changing the density of the water absolutely is going to affect the position of the egg. But then the question is, why?
I'm gobsmacked that that's how you would explain that, because that for me is it's non sequitur. No, that's not the word. It's not non sequitur. It's what you're doing is you're coming outside of the scientific method to include something to make it try and sound scientific, when the absolute scientific method states that the independent variable causes the dependent variable a cause and effect relationship. And by causing that cause and effect relationship, you establish what is causing the experiment to do what it's doing. But then what you're doing is dismissing that, substituting something else, call it an explanation, and then expecting that to be satisfied and therefore accepted. I can't accept that to be the case, because that's not scientific.
I think to me, the scientific method is, I think we start off and we agree, absolutely, you observe your phenomena, you get your hypothesis, you get your independent variable, etc. But it doesn't stop there. If I was talking about, how somebody putting weight on, for example, the more calories you have a day, the more weight you put on, right? That is a link. But then the question is why? Why does those extra calories cause weight gain? And then there's more questions to be asked, and you dig deeper. Now, I think with the egg, let's say nobody had ever mentioned gravity. Let's say gravity had never been mentioned. Nobody ever knew anything about it. We put the salt in the water, the egg moves. I would still then be following that scientific method and saying, right, density has an effect on the equilibrium position of the egg. Why? And then I would look at other questions and I would look at other experiments to try and find out why that will be. But in the position of the egg in the water, those experiments that I'm talking about that look at the foot, they've already been done historically. So instead of having to ask that question and go forward, I can then draw on the experiments that have already been done. But to me, asking the question why that's the whole point. It's not that you identify a link, but then you've got to ask why.
So which experiments? Yeah. Which experiments?
Yeah.
You said you draw on the experiments that have been done. So which ones?
So you broke up a little bit there, Nate. Sorry.
Which experiments? You said I just draw on the experiments that have been done already when I draw that conclusion further to the experiment that's undergo. So therefore you're saying there's an experiment that already validates gravity, right?
There's absolutely experiments that validate forces being linked to acceleration in terms of objects falling to the ground. I can absolutely link, as we all can, the weight of an object to its acceleration, how it's pulled to the ground, and I'd apply that to the salt and the egg.
Yeah, but you can't answer the why. That's the problem.
Well, for me, the why would be, I know that, for example, force equals mass times acceleration, and if you increase the density of the water, you are increasing the mass of the water. So that is going to increase the force that we know exists and can measure. That's accelerating that water downwards. Now, if you
okay, listen, let's stop this for a second. We're talking about Newton or Cavendish gravity. Let me ask you a question.
Okay.
The scientific community, whoever or wherever they are, don't follow Newtonian or Cavendish gravity. Why are we even talking about this?
I totally agree that there is massive confusion and an inability to articulate how gravity works. I don't know how it works, but the observed phenomena for me is things are pulled towards the ground, and we can't ignore that. Now, I can say, well, there is a downward acceleration force. I can't explain how it works, but it's a consistent downward acceleration force of 9.8 meters per second squared. And we can't ignore that being there when we're looking at experiments like the salt and the egg.
Do you observe the pulling force, really? Because that's what I can't wrap my mind around it. Pulling force cannot be observed. I mean, that's an invisible magical force.
It's the word pulling that I've got an issue with, because what we're really seeing in real world is displacement, which isn't a pulling force or a pushing force. It's a displacement, right? But I don't know how you make the leap from displacement, in other words, refinding its equilibrium, to a pulling force that pulls it down. To me, we're observing displacement. We're not observing a pulling force you're right. You're demanding that it's a force, and I'm like, well, no force is necessary. We see displacement, and it'll refine its equilibrium. If you push it out of, if you make that egg go into a state of disequilibrium, no force is going to push it back into its state of equilibrium. It'll just equilibralize itself by virtue of its density in its relative environment. But you're
because as a thought experiment, like you said before, if you were never taught gravity, how can you observe the pulling force? How can you come to the conclusion that there's a pulling force?
Well, sorry.
There you go ahead.
Yeah,
No,
yeah, we can observe. We know that force equals mass times acceleration. We know that that has to be true. And when we look at the egg and we pause, the egg is in equilibrium. It's not moving. When we put the salt, in the water or whatever, when anything moves, it has to have an initial acceleration. It has to. It's going from no meters per second to X meters per second, but that is an acceleration. And all accelerations require a force.
Yeah, but you have a potential energy. So if Neil deGrasse Tyson picks up a microphone, he immediately puts potential energy into that microphone while it's in his hand because he's picked it up from the ground. So when he drops it and asserts gravity, he's inserted potential energy into the microphone by picking it up.
Yes. Yeah. And potential energy being mass times gravity times height. And the way that works, is do you know the difference between potential and potential energy? Have you come across the difference between the two terms?
The potential and kinetic energy.
No, potential as in gravitational potential and gravitational potential energy.
Yeah, no, because I dismissed gravity.
Okay.
And you're talking about it's a force. Well, Newtonian gravity is a force, but the scientific community doesn't follow that. Einsteinian gravity is not a force.
I would say if somebody dropped a piano on my head, I would feel the force, and that's that's kind of like what I'm saying. I wouldn't want to be stood underneath something when someone let go. I would feel the force.
Yeah, but that doesn't mean that you have to define what gravity is, not pianos. And by the way, the length of something is not an independent variable, just to be technical. But you have to define the why. We have to know the why. We got the 9.8 meters per second squared. Got it. No, not a problem. Why? What is the cause of that? That is the point of the discussion.
Absolutely. I totally agree. And that's what I was saying before. You get your link, and then the next question is always why. Now, to me, there's two options with the egg and the salt water, right? The why could literally just be the densities are different. But then that begs other questions. Why is there a directional component to that density gradient? Why did the more dense things always settle closer to the Earth and the less dense thing away? There's a very, very obvious directional component. So my next question to that would be, so let me ask you, why is there a directional component if it's down to density alone?
That's an excellent question, but you already have an answer to that question, don't you?
Well, no, I know what my answer would be, but what I'm saying is if I can't use the force of gravity, then, is there, I'm new to all this, it has, I'm sure you've heard a lot of these arguments before. So have you got a different model for that I can go and look into?
Well, this is
now,
the
we
thing.
already talked about models or pseudoscience.
Well,
and number two,
sorry, John. Just bear with me 1 second. You're right, models are pseudoscience, but what I'm saying is you don't need to come up with an alternative. There's no necessity for us to provide you an alternative. Now, we may or may not have one. But that isn't the point. You're already asserting gravity. So we're saying, well, what have you got for it? And as you found out yesterday with Anthony, you haven't got any scientific evidence to back the assertion, but you're still making it.
Okay, so there is absolutely a force which we can measure, which accelerates objects to the ground. Are we all agree on that?
No, disagree.
See?
Okay.
There's not a consensus even.
Validate the force.
Disagree.
Well, I can measure the force.
You're calling it a force, but it's not a force. You're just measuring 9.8 meters per second squared. That's all you're measuring. What's the cause of that? What's a force?
Well, force is something that needs to be applied to an object to change its size, shape, speed, or direction.
Yeah, but what is it? Give me do you have a picture of it? Give me, I need something tangible.
And I think this that's a brilliant question, and that is where kind of like my understanding is that's where the cutting edge of physics is. I don't think Brian Cox could sit here and articulate that for you.
Sorry, you're wandering off the point though. You're saying it's on the cutting edge of science, but you already have an answer to this question, and you say gravity.
Hello.
Right?
We have the mathematics to predict how it works constantly.
Well,
that's a problem.
Stop, please. Mathematics does not make scientific predictions. Scientific predictions are very specific. Scientific prediction is a hypothesis. It's the interaction between the independent and dependent variable. So no Mystic Meg predictions here, no Nostradamus predictions. Scientific predictions are very specific and defined.
Well, I know if I take an object of a known mass and I drop it from a known height, and I've got a high-speed camera at the bottom of the building, I can use the science to predict exactly the speed it will hit the ground at.
May I say something in here? Now, I'm serious, and it's about people excluding themselves from the formula. Listen to what you're saying. I take an object, I drop it. Now, I exclude myself from the reason it has its potential in the first place. Just like the feather and the bowling ball in that one video that a lot of people know and recognize. How did that bowling ball get up to the girder, and how did that feather get up to the girder and get to their release mechanisms? On a scissor lift, probably. A man or woman had lifted them up there, installed them there. And then let's move them, and they're giving those objects potential energy out of the equation. Let's look at Newton's apple in the tree as magically falling, as not having a reason for being there. So they're making gravity an imposter, a stay for excluding, giving a way out for people to exclude themselves from this formula, for excluding why an apple grows in a tree and stores potential energy.
Did you say hello? Sorry, James, to interrupt.
Which is gravity, and then they take you out of the picture. Same as looking at things from the side. Instead of being a first-person view, now they've made you an imposter at the side, looking at everything in absolute value.
Yeah, listen. Let's not divert away from this. I hear what you're saying. Yes. Just hold on a second. We got too many cooks in the kitchen. Let's get back to the prediction part. I want to make sure that we're on the same sheet of music with this prediction, because everyone uses this word. They equivocate fallacy out of their mind. A scientific prediction is a very specific thing. Are we in agreement?
Sure.
A scientific prediction is a hypothesis. So if you don't have a hypothesis with a viable independent and dependent variable, then you don't have a scientific prediction.
But I would argue that, if, in the example of, force, I would argue that my independent variable would be the mass of the object I'm going to drop. My dependent variable would be the force that it hits the ground with, for example, or the force exerted on the Newton meter when I let go. That's a very clear independent dependent variable.
No, it's not. Do we want to go through this?
Yeah.
Do we want to go through this?
Yes.
1 second. Let's put it up there so everyone can see it.
And really quick for the teacher, when you say we have observed this, we have experimented, have you been part of the body of science that already presented us this, or you're just adopting what has been presented to you and regurgitating it forward? Because when you say we, I feel like you have been part of it. Right.
Well, I calculate, acceleration of falling objects all the time at work. That's part of my job. We get the kids to do it. I do personally make predictions about how fast something will fall and hit the ground from a certain height, and then I do that, and how the mass will affect it. I make those predictions, and then I calculate it. We do that all the time. So, yeah.
Okay, so if you can click on John's thumbnail in the Hangout, bottom right of the Hangout, just click on John.
Right. Okay. Yeah. Well, that's cool. Right.
Natural phenomena observed, please.
What, sorry?
We're going through the steps right here. Step 1, step 2, and we just need the first 2 steps. So what is the natural phenomena that you observed?
The natural phenomenon is that let's just say a mass will move towards the Earth.
A mass. Now, how do you know mass? Can you see mass?
I can measure mass.
You can measure mass.
Mm-hmm.
How about just things fall to the ground? How about that, so we don't get bogged down here?
Okay.
Is that okay with you? I don't want to.
Yeah,
I don't want to put words in your mouth.
Yeah, no, it's fine. Objects, yeah, but can we put? They will accelerate to the ground.
Okay, so apple falls from tree, accelerates to ground. Happy days.
Yeah.
Okay, so we can go down here, right? Hold on a second. Because your observed phenomenon is your dependent variable.
Yeah.
So we can go down here, 1 second. Hypothesis.
I wouldn't say that the objects accelerate is a dependent variable. I would say that the rate of acceleration, or not the rate of acceleration, the force that they accelerate with is a dependent variable.
You can't do that. You're begging the question. Your natural phenomenon is always the dependent variable. It's always the effect. Now we're trying to find the cause of that effect.
Right. So for me, my independent variable in this would be to.
No, I want the hypothesis.
No, so the hypothesis is objects with a bigger mass will accelerate to the ground with a bigger force.
With a bigger mass will accelerate to the ground with a bigger force. You're impugning a force here, but that's all right, no problem. Let's just move on. What is the independent variable?
That will be the mass of the object.
Okay, so mass of the object causes objects to accelerate. Where am I at here? So the mass of the object causes objects to accelerate to the ground
with a different force.
You can't say that because you don't know if there's a force or not.
Well, when I say force, I'm talking about measuring with a Newton meter. So whether you call that a force or not, I'm measuring, with a Newton meter. I'm going to call it a force.
Did you say Newton meter?
We're not going to Newton's meter. So does this make sense to you, or is this just a tautology? So mass of the object causes objects to accelerate to the ground. What have you answered here?
Well, no, I wouldn't. I would say the mass of the object is going to affect the force that I measure on a Newton meter.
That's what I'm talking about. You're already coming up with forces in Newton meters. I mean, it's circular. It's begging the question. The mass of the object. This has to be.
We're talking about weight, aren't we? That's what we're talking about. Objects with a bigger mass clearly have a bigger weight, and weight is gravity times mass. Weight is a force. That's what when we talk about the force, that's what we are talking about. Weight is the force.
So let's just stick with the hypothesis and the experiment. So what's the null hypothesis?
Well, that it doesn't affect it.
Objects that what doesn't affect it?
The mass will not affect the weight of the object.
Yeah, but we're getting into weight here.
Ranty, is that you?
It is.
Weight is, I think the definition of weight is weight is the force that I'm talking about. When we times mass by, gravity, that is the formula, that is the equation that gives us weight. So things do have weight. Weight is also directional. We see that all the time. Weight acts downwards. If I sit on an elephant, the elephant's fine. If an elephant sits on me, right, I'm going to get squashed. Or if I'm sat on the elephant, sorry, I'm fine. It's not squashing me from below, but it will squash me.
Yeah, but you're talking about weight here. Weight and mass are different. We're into your hypothesis here, and it's just talking about mass.
I'm saying the mass will affect the weight. They are different.
But this isn't telling us why the mass of the objects causes objects to decelerate to the ground.
No, you're right. It doesn't tell us why at all. It doesn't tell us. What we do is we identify the link between the two, and then we ask those questions why.
Yep.
And that requires other experiments and other hypotheses, and it's a long
process. No, we have to do. See, we're not to the experiment yet. We're just trying to set this up because we're going to the experiment right after this.
Hold on, John. But can I just point out what you've done there? So we've not even through, as John has just said, we've not even got to the experiment stage. We're just trying to formulate the hypothesis. And you've already got the answer. You already know what's going to happen and what the cause is. You already know what that force is and what its name is and how it's measured, right?
No, what I've done is I've identified my independent variable, which is going to be the mass. And I'm then going to measure the weight of the object. Right, and as I increase the mass, I'm going to look at the effect of the mass on the weight.
Okay. Do me a favor. Can you define mass?
Mass is essentially the amount of material that you're made of.
And that is not the correct definition of mass. Do you know that mass?
Be the textbook definition, but that is essentially what it is. It's the amount of material that you're made of, whereas weight is the force that you feel when that material is pulled down on you.
Do you see my screen?
Yeah, the amount of matter, it says there.
Nature doesn't. This is from Professor John Wheeler and Edwin Taylor. What is mass? Nature does not offer us any concept as the amount of matter. History has struck down every proposal to define such a term. Even if we could count the number of atoms or by any other counting method try to evaluate the amount of matter, like you said, that number would not equal mass.
So what we do is we get a reference point, and we get and the standard 1 kilogram masses that are out there. We slapped a number 1 kilogram on something, and we essentially say anything that has twice the mass of this is going to be 2 kilograms. Anything that has half the mass is going to be 0.1 kilograms.
Yeah, but it's not actually mass. Because you haven't defined it yet. I know where you're going with this. I got you. But you still haven't defined it.
To me, it's just the amount of stuff. I mean, we all know things are made of stuff because we can touch stuff. And I'm just saying the more stuff something has, the bigger its mass.
Yeah, but I know. And he just said no.
Air is stuff. Can you touch it?
No, don't go off. And I understand what you're saying. I got you. But Professor Wheeler just said that that's hogwash.
I think that quote needs a little bit of looking into. I think perhaps
it's not a quote.
Interpreting what you're saying there.
It's not a quote. It's a citation, and it's pretty dang clear what he says. Right? And hold on a second. That's pretty clear.
When he says that number would not equal mass, do you mean the number of atoms? I mean, what number?
The number of atoms.
Right. Well, the number of atoms definitely doesn't equal mass because all atoms are different sizes. So like something like uranium has an enormous atom. Something like hydrogen has a tiny atom. So if they're made of the same number of atoms, they're not going to have the same amount of mass.
I understand that's a straw man. I understand that, but you said it was the number of stuff in something.
Yeah, the amount of stuff. Yeah.
Yeah. So the stuff is atoms. I don't care if they're different weights.
Well, the atoms inside them have protons and neutrons and electrons. That is the stuff. So the number of protons, neutrons, and electrons. Then let's define it as that: the number of protons, neutrons, and electrons.
Yeah, atoms.
No. That's like saying the number of bricks is the same as the number of houses, and that's not true. You can't say that I've got 3 houses, you know, therefore they have the same amount of bricks as the 3 houses I've got over here. We wouldn't say that, and it's the same thing here.
Define mass, please.
But let's define it now for the sake of it as the number of protons, neutrons, and electrons. Let's do it that way. But it's definitely not the number of atoms.
I'm speechless.
Those are molecular weights. You don't count them.
I don't care. Let's go back. Let's go back to the hypothesis. All right, because it really doesn't matter. You haven't answered anything here. This doesn't. It's nothing.
Right. When you say that, like, I can take an object that has more stuff in it. However you define mass, I can take an object that has more stuff in it. I can place it on a weighing scale, and the force that it presses down is obviously going to be bigger. You know, the amount of stuff does affect the weight of an object.
Okay, you're still calling it a force. I'm going to tell you right now, right, that gravity, the one that the scientific community follows, is not a force.
Hello.
Right? Let me just say this from George Musser in Scientific American. Einstein created his general theory of relativity, which provides our modern understanding of gravity, with the express purpose of expunging non-locality from physics. Isaac Newton's gravity acted at a distance as if by magic, and general relativity snapped the wand in two by showing that the curvature of space-time and not an invisible force gives rise to gravitational attraction.
I think the sticking point is obviously going to be the definition of a force, or the understanding of what a force is, isn't it? To me, like I said, it will change the shape of an object, the size of an object. It will speed things up and slow things down. Now, if you don't want to call it a force, that's fine, but we can't deny that if I take something that's got a lot of mass and it's heavy, and I put it onto an egg, it's going to break the egg. You know, if I put it into it, it's going to crush, you know, it's going to crush a balloon or whatever. Right. There's clearly an action that when I increase the mass, I get a bigger effect from it.
So you're saying mass causes gravity?
No. The gravitational field, right? An object in that field is affected. The objects affect each other, and there's a force existing between the two. But you can have the gravitational field without a secondary object. So the Earth's gravitational field. This is why I was asking about potential and potential energy before. Any point of the Earth's gravitational field has a potential. And then when you place an object into that point, depending on the mass, the potential energy of that object will be given. But essentially, and I actually forgot what your question was, and I was waffling on. Sorry, guys. John, go on.
You said a gravitational field. What gravitational field? Newtonian or Einsteinian?
Well, and that's what it's. We can't explain that at the minute. We can't explain how it works.
Then we don't know the why. We don't know the why. We say gravity. That's why I said anytime that they invoke gravity or say that word, they immediately invoke a cause, whether they know it or like it or not.
I see where you're going. Yeah, I get what you're saying. I think we actually agree. I do. I get where you're going. All right.
Okay.
And I do think I agree in terms of. I was saying before, you've got to ask that question why. You've always got to ask that question why. Yeah.
Right.
Now we do know that when I have something with more stuff, it will weigh more on a weighing scale. But then what you're saying is why. Okay. And that why, when you dig right down, we have to explain exactly the process that's going on to change that, you know, exactly the process that's going on that's causing that object to be pulled down onto the weighing scale. And we can't explain that at the minute. Right. So I understand you're saying, well, why, you know, when we boil right down to it, no, we can't explain what causes that. And I totally agree, we can't.
Well, can I just interject there? Sorry, but hold on. I must interject. So, I'm super stoked that you've agreed. However, people in the scientism community assert that it is proven with an experiment, in quotes, called the Cavendish experiment.
So the Cavendish experiment, to me, right, would calculate the gravitational constant, but that didn't explain why the two balls moved. It didn't explain the mechanics of how gravity worked. What it did is it gave us something to allow us to constantly make accurate real world predictions and applications that will work time and time and time again. But
those aren't predictions. They're not predictions. They're not scientific predictions.
Well, when I said what I mean is I like the predictions I make in the lab. If I decide to change the mass of an object I'm going to drop from the ceiling, I know exactly the speed it's going to be traveling at when it hits at the floor, and I use gravitational constant for that. Right. So the number that came out of it does have a use in the real world. But no, I would never sit here and claim that anybody knows exactly what that mechanism is, exactly what that process is. But what I can say is that it is definitely distinguishable from density, and it's not density.
Yeah, well, I never claimed it was density. I don't know. I can't explain it because I can give you an explanation, but in science, the explanation has got to be accompanied by experimental validation.
It sounds as though we're pretty much saying the same thing.
Yeah, somebody's echoing real bad.
Is that my mic?
No, it's Mona Lisa. Is that Mona Lisa in there?
It sounds as if we are saying exactly the same thing. And I exactly what you said then is what I said before. We always have to go on and ask that question why afterwards. We've always got to do it. And we've got to keep on asking why. But I don't think that we can ignore when we come up with something mathematical that allows us to calculate all the things that we can calculate using the gravitational constant, and then we could see those things happening in real life.
See, you call it gravitational constant.
Well, that's the name of the constant. Now, whether we could call it whatever, the name's relevant, but that mathematics does prove to be true. Whatever you call it, but that doesn't.
I've got to stop you. I'm really sorry to interrupt. I'm really sorry, but it does matter because there are connotations that come along when you call it gravitational. That means something.
So, to me, and I think I'm getting what I think I get what you're saying. Okay, I think when you hear gravity, are you thinking of like a process, a procedure, some kind of like physical process that we claim to understand? Is that what you mean?
No, I mean that the connotations attached to that word are either objects of math, but either Newtonian or Einsteinian, and both involve balls, the Earth, spinning through an infinite space. They're both wrapped around the same bullshit.
Right, so you're linking it to the.
Would Al agree with Professor Reese here? Are you seeing my screen here?
Yeah. What causes gravity and mass? Yeah.
These questions still baffle all of us, right?
Absolutely, they do. Yeah.
So, according to Professor Reese, does mass attracting mass cause gravity? Nope. According to Professor Reese, does space-time cause gravity? Nope. See what I'm saying here? There's built-in contradictions. Once you dig underneath the surface, they already know it, right? He's just telling you straight up right here, right?
Well, I mean, I'm saying exactly the same thing. We can't explain what that process is, and go back, 100 years, 200 years, we couldn't tell you what the speed of light was. There's lots of things we couldn't tell you. I can't tell you now how it works, but we don't have to. There obviously is something that causes objects to have a weight.
No, go ahead and let Al finish. No, go ahead, Al. You finish.
Well, so there is obviously something there that causes objects to have a weight, and the more stuff we put onto a weighing scale, the bigger that weight reads. We know, that the springs are being compressed more in that weighing scale, which demands a force. If I'm going to compress something, compression is a force, isn't it? So there is something there. Now I'm gonna call it gravity, but I can't explain how it works. But when we get the numbers that allow us to make accurate calculations and predictions of what is going to happen.
Predictions again. Okay, sorry.
Oh, you're right. Go on.
No, that's okay.
We get the numbers from falling objects, and we don't ask, well, how did the object get its potential energy? It becomes like an exercise in magic. And then we personify the force as a thing called gravity. Now, if I pick up a microphone and I drop it and pretend I'm not in the equation as giving it the potential energy to fall in the first place, then is that science? Is looking at a bowling ball and a feather on a beam on a roof there, hoisted up by a scissor lift and stuck there with quick release pins, whether you add a red herring of evacuating all the air and making it a vacuum and dropping these objects, do the people who raised them up there and positioned them there and gave them that potential to fall not count? Only magic gravity, as soon as you release them, is responsible. Right back to the apple in the tree. It grew in the tree. The tree, the sun, the photosynthesis stored water and fleshy stuff up there. Not a big mystery. And when it was heavy enough, well, had enough mass and couldn't be supported by its little stem, it fell. And it wasn't gravity pulling it to the ground. It was stored energy above the ground. Gravity's not involved. If you ask how something got in the air and in a state where it's going to fall in the first place, you know,
but I think Al realizes that the problem here is the word, because the word carries baggage with it, and the baggage is not scientifically validated.
Right.
We agree on that, Al?
Sorry to interrupt, because we're just about to have maybe a 5-minute break. So the point of interjection, very valid points, James, and I totally agree with you. You've got to pick the microphone up and put potential energy into it. I completely agree. But the point that John interrupted you was where you said the word prediction, and you had strayed off science into mathematics and then used that word prediction. So we're not talking about scientific predictions anymore. We're talking about Mystic Meg predictions, Nostradamus predictions, not scientific predictions, pseudoscience predictions.
Predictions are not science at all.
Go ahead and let it help.
Sorry, the type of prediction I mean is literally, you know, I'm going to call it a prediction if you want me to use a different word, but if I drop something from a known height of a known mass, I can calculate what speed it will hit the ground at, and I am right 100% of the time. To me, I call that a prediction.
Right, but it's not a scientific prediction, though. You understand that, right?
But it's not a guess. I'm using equations derived from experimentation.
That type of thing is akin to, say, looking at the position of a star over and over for hundreds of years and being able to predict on a certain date where something's going to be. That's not scientific, but it's prediction. But it uses zero science and only observation to make a prediction.
Jose, that's a really, really good point. And that's the point I make in the video that I put on my channel earlier on. That the reason that the equations I'm using to make those calculations, to make those predictions, use data that have come from Eratosthenes, that have come from the Cavendish experiment.
It's not an experiment.
Well,
non-experiments that assume.
Yeah, I got you.
Yeah, we're not talking about experiments again. We're kind of going around in a circle, so I'll probably see that as a good opportunity to round out this show. So I'll say first and foremost, a huge, massive, enormous thank you to all of the live audience for tuning in and hopefully sharing this debate. And of course, a massive thank you to all of the debating panel for making this debate possible. If you hated the show, then you know exactly what to do. But if you liked the show, maybe consider subscribing or sharing with a friend. I've been Nathan Oakley, and I'll see you all in the next video.
Oh, what a day! What a lovely day!